Hi, today we are going to look at all the latest developments happening across Facebook AI on Textless NLP. Here, this blog post proposes that it can perform NLP tasks on voice inputs without ever converting it to any labels over text. They call this model as GSLM or Generative Spoken Language Model. So let's first look at the output of the video.
When an aristocracy carries on the public affairs, its verification there may be in science, the connections of the valley to which it was called upon to lecture, conferring on similar descriptions of opinion, and in other instances which appear to have never exceeded the same results. It cannot be found that the notion of the most ideal opinion is the popular notion of the edifice, nor is the susceptible possibility of introducing the same stake of the continental character. The scope of the theory of the notion of When an aristocracy carries on the public affairs, it's coming to the chronicles of the public jurisprudence as to what is observable, not naturally demanded of it, by the way in which postal axes are adequate delayed by freemen, and especially kindering the same stock. No body of postal acts has ever been demanded to labor, and any stock was personally adequate to labor. End of section 19. When an aristocracy carries on the public affairs, its taste of a grading makes up a precedent, and such is the aristocracy of past correspondence. The past correspondence has not been accounted, and the capital is reckoned under the apparent estimate of a capitalist industrial population governing the public population. For aristocracy is valuable to the public acceptance of this kind, for having nobodies to sympathize with it, and when a capitalist is within 20 years old, the population is said.
So what we saw in the video was based on the few words which was present on the input text, input speech. Our algorithm was able to provide more context on the knowledge, plus add some more, add the same voice type in the speech without ever converting to any other NLP task. Here, the model has been generated and extended the speech with the same voice without ever converting it to any format. It has only been trained on 80,000 hours of audio from audiobooks. It has been a series of research which has been happening at Facebook AI for Textless NLP. So we will be going over 3 research papers which covers Textless NLP in one video. It would be interesting but possibly a long video. However, I would try to only focus on most of the important ideas and will skim the rest of the parts. If you like this content and want to support it, please hit the like button. Also, for regular updates, you can subscribe to this channel and can follow me on social media, which will be mentioned in the description. Any suggestions, opinions, or clarification can be expressed in comment section. So let's go over the first paper, which is the architecture, the GSLM paper. So let's go over the first paper, Generative Spoken Language Model from Raw Audio. Generative spoken language modeling involves learning jointly the acoustic and linguistic characteristics of a language from raw audio only, without text or labels. We introduce metrics to automatically evaluate the generated output in terms of acoustic and linguistic quality into associated and to-end tasks respectively. Speech resynthesis, that is repeating the speech input using the system's own voice, and speech generation, producing novel speech outputs conditional on a spoken prompt or unconditionally and validate these metrics with human judgment. Okay, so basically on NLP tasks, our models usually get trained on textual data. Model such as BERT or GPT and all other text-based language models get trained on text-based data only, even if the input or output is of voice types. An intermediate layer called as ASR system needs to be added to convert voice or speech to textual format. So if we have text format and if there is a but, then if this is an encoder decoder problem, so it can the transform model would be taking an text as an input and it will provide a text as an output also. But if there is a voice, so let's add the voice also in a waveform. So that needs an additional ASR system that actually converts the speech to text, and then we can apply BERT or any other transform models according to that. Now it's possible that our ASR model would be inefficient or worse, doesn't convert the language of the speech to text, and all of all of this hampers the pre-trained language models and the model's accuracy. This is the kind of problem that GSLM tries to solve. This model architecture can work on speech resynthesis without any dependence of the language of the ASR system. So without the ASR, now our speech will be independent of any of the language pre-trained ASR models that we or any of the usually use to train the models. For this paper, actually they have just applied a baseline metric system to validate. In this, all the architecture actually just takes the state of the art model for each segment and then tries to solve is this the better approach or not, which we will be looking out. In this, the most important topic was to validate and figure out to how to automate this ASR based matrix for these models. So for speech generation, there are yet three things to consider. Encoding for acoustic modeling that represents speech in terms of phonetic content but not of other acoustic factors like speaker and noise. Like similar words like ba, cha, da, the similar words like si, the words. Language modeling assigns high probabilities to frequent lexical or syntactic patterns. Now, it has to also understand the similar or the words which are actually contain the same meaning but different words. Generation for acoustic modeling, resynthesis capability that can repeat the same textual content with a word voice of choice. This is just the thing that we have seen on a video also, where the voice of the input sequence was same as the voice of the output one. Now let's look over the architecture. So here's the architecture where there is an encoder, the H2U, which encodes the speech to low bitrate discrete pseudo text units Think of the pseudo text unit as a machine code where it's not understandable to us what is it is. However, the machines understand it correctly. A unit-based language model that learns the probability distribution to these learned unit sequences, and then the decoder which converts the units back to its waveforms. There is an external evaluation block for computing the matrix. Now for this part, they are using the ASR to convert the speech back to text and then compute its matrix. If you think these units I have mentioned, which is similar to text, what we have used, then you are correct also. The author has mentioned this in the paper also, if we can see. Here. The S2U, ULM, and U2S models become automatic speech recognition, ASR, character, LM, and speech text to speech models, which doesn't mean that it defeats the purpose. It is just that what they have mentioned as the unit, the low bitrate unit, it's similar to the text that most of the architecture uses. But this is the main interesting part, which the unit discrete parts actually contains more context and is free from the NLP, the language burdens that usually we have. Now, they have also provided 4 speech-related tasks which happens on a block, which are acoustic unit discovery, which learns the pseudo text from the speech in the an S2U. Discrete resynthesis, now which converts the speech into speech via pseudo text bottleneck from S2U to U2S. Spoken language modeling learns the probability distribution of language model, which is from S2U to ULM. And speech generation, this actually focus on the utterances that conditionally or conditionally happen on speech, which move from ULM to U2S. Now, let's go over the evaluation. Um, that we will be going over the idea that how they have proposed a system for evaluation of this architecture. Now for speech to unit models. For speech to unit models, as we have seen, uh, basically the idea is that we have the speech in terms of waveforms, and then we have to anchor it in a way that actually converts it into a machine readable format, which mostly, so for this part actually they are using 3 types of modeling which they have provided. First is the CPC, then the wave to vec 2.0, and the UBERT. Now CPC, or what we call as the context predictive coding. This model consists of 2 components, the encoder and predictor. The encoder takes the speech as an input and produces the embedding Z. The predictor attempts to predict the future stage of the encoder based on the past history and, and optimizes the consecutive loss comparison wave to wave. Now, this also contains the encoder and the decoder, like the CPC. Here, it distinguishes the positive and the negative samples from the discredited stage and a mask segments from the encoder's input. And Hubert. It is a similar to BERT, where it it is like a mask language modeling, where it actually masks the specific parts on the audio signals. If the audio signal is like this, it will mask a section which uh, let me go up the pen, which would provide the output as in what should be in these sequences. This would be masked, so there wouldn't be anything on the input, and then the model should provide the actual output of the audio signal. Now let's look over the ULM or unit language modeling, which is this part. Now for this thing, they have used actually the transformer models for that. As they uploaded, we use the transformer model as implemented in the phase sequence. We use the transformer alembic architecture. It has 12 layers, 16 attention heads, embedding size of 1024, feed forward neural size of 496, and dropout probability of 0.1. Each sample contains up to 3072 tokens. This model is trained as per causal language model on sequences of discrete units pseudotasks. Language generation is performed through sampling with temperature. Now, the phase sequence is similar to what we have for Hugging Face, where specifically it helps us to custom train on a pretrained model and provides us a better result. We will be looking at the different the outputs that we will be getting from the voice in terms of the temperature also. Now, let's say the unit to speech model. For unit to speech, they have used the Tectlom 2 model, which just takes the discrete units as input and outputs a log mesh spectrogram. Log mesh spectrum is equivalent to the voice output voice equivalent file type that usually use. Finally, we can see the results of the state of the art if implemented in the architecture and how it will perform. On the resynthesis task, they have provided all of the output in terms of the models that they have provided, and based on that you can see from the ASR the actual values. Our architecture provides better results than other models without knowing the main context on that. Now they have now they have using their own metric, ASR based metrics and human opinions. So this needs to be evaluated more further. Now for generation tasks also, their the models have been providing more accuracy on that, which is what they have provided in the paper also. Now let's look over the temperature differences on the model which they were mentioning. So here are some examples where they have checked out the outputs in terms of different temperatures. Now with a low temperature, let's see the output.
The Property by James Resselol, read for LibriVox.org by Jason Downey. The Property by Jason Downey. The Property, the Property, the Property, the Property.
Clearly we can see that there is still some voice under problem is there. The property, and it couldn't provide the output sentences. Now with the medium temperature, we can get some
But
very
it is
information.
intended from the people to defend himself. From this information pride of the potential. in criminal activity, curiosity, and impetuosity of the world were soon acquired.
We can see here also there were some words were missing. Now in the high temperature, it is possible we would be getting better results, but there could be some words which are incorrect also. Let's see.
Of pure blue. He said at once, licking stream, at her one spot, haffer from node, was a raging of fluid has beer of a mollieren. Mood strolling air crass was
Clearly, as we have seen, now it was clear that the high temperature does provide some words which are not understandable. The medium was okay, and low temperature does provide a better words, accurate words, but it wasn't providing more values in the context, if you understand that. So here they have provided the examples on the conditional and unconditional examples. In conditional examples, they have provided the audio, and then the model's idea is to provide the extend the audio, the speech in terms of the voice also, and what the context also. Now let's hear
Cried one of the women. He took no notice of her. He looked
in Lockman.
She took no notice of her. He'll there persist. Half as her just. Cried one of the women. He took no notice of her. He looked up and saw that it was a great pity. He saw the baby who was being called.
And supervised. This is the original audio that
Cried one of the women. He took no notice of her. He said the other had heard her say that she was a traitor and that he was a coward.
definitely we can see that our model was providing a better results, and it was working as they were expecting. This is the unconditional one, where the pseudo text has been provided to them, and it just said they want to decode the pseudo text into speech.
Thus fully wrote. Violatrix, thumbly special of regress, oily in fastros fall, fully with 3 seats, 12 streets, But now we shall be there, they said. Then I will go into the lion to pay the price for them. They went on as well as many other best people. They went into the big back room where we were, they said. One of the men who had saved the country suddenly stopped his horse and released his horse, standing on the top of the cart. He saw the bear floundering about. He could not see where he was going, nor did he see the bear or the bear in the distance.
However, we can see here that the values that our model is providing is not up to the mark of the supervised value. So here is still some of the research needed to go upon. Now we would be looking at the second paper called as Expressive Resynthesis from discrete disentangled self-supervised representations. So first go over the abstract. We propose using self-supervised discrete representations for the task of speech resynthesis. To generate this entangled representation, we separately extract low bitrate representations for the speech content, procedure information, and speaker identity. This allows to synthesize speech in a controllable manner. So overall, here we can actually provide the whole idea in this architecture only. Let me send it out. Okay. Now here there is an audio signal that is the input. Previously we have seen the speech to unit model, if you had remembered from the GSLM paper. So this is the same architecture where we have the CPC Uber pretrained models of the speech recording, and it provides a discrete embedding of the values. They have now added the pitch to unit model and speaker embedder in the encoder. Adding of these architectures, the encoders is now they want to get the prosodic information from the audio signal also, which actually represents the intonation, spreads, or rhythm in the sentences. Using these techniques, they were able to generate the voice from other people's, and they were able to generate the speech from people who haven't spoken to the same sentences beforehand. Be- because of that, they have added the speech to unit model, which is a convolutional encoder using the rest block, which we can see, which also provides a discrete outputs, and it mostly is focused on getting the frequency of the pitch from the audio. And the speaker embedder, this is just a pretrained model on the speech, and it provides a global representation of the audio values. Now basically after that they have been gone to the vocoder, which is just a decoder to convert the encoders, and it provides a more on terms of the speech resynthesis in the audio segment without using NLP understanding in the audios. We can see the help of the prosodic information that we get from the architectures from this example.
The morale of the Yugoslav army is beginning to crack.
Here, an input by audio is being provided of the user.
It was important to win the singles.
And then a reference voice was provided. Based on the voice of the reference, the output would be the values of the voice of the original user.
The morale of the Yugoslav army is beginning to crack.
Now, this is something that actually previously most on the NLP task was being used, which in this paper they have only used the voice-based and NLP task, which has provided the same values to convert these values. Now, finally, the final papers, we can get more information in the blog post than the paper, and it doesn't provide a similar a new architecture. It is more on terms of merging the first two papers and providing the expression on the audio signals also, where the unit embeddings is being provided, a delay of the embeddings, and the duration and the speech embeddings is being added, and a multi-stream transformer is being added to provide the outputs. It is similar kind of RNN models where the input is being decoded to the output, and the same is being provided to the input for the next sequences. Based on this idea, now it's the same thing that we have seen on our starting video, where the original sentence was being provided, and based on the original sentence, there was a continuation in the audio signal also, thus the same voice was being used.
When an aristocracy carries on the public affairs, its national pride naturally assumes this reserved, indifferent, and haughty form, which is imitated by all the other classes of the nation.
So this was an input.
When an aristocracy carries on the public affairs, its verification there may be in science, the connections of the valley to which it was called upon to lecture, conferring on similar descriptions of opinion, and in other instances which appear to have never exceeded the same results. It cannot be found that the notion of the most ideal opinion is the popular notion of the edifice, nor is the susceptible possibility of introducing the same state of the continental character. The scope of the theory of the notion of the...
And there was some continuation from the audio also.
When an aristocracy
If you can hear the translation, the voice, the breaking of the speech is also being perfected now because it has contains the prosody information of the sequences.
on the public affairs, its taste of a grading makes up a precedent, and such as the aristocracy of past correspondence. The past correspondence has not been accounted, and the capital is reckoned under the apparent estimate of a capitalist industrial population governing the public population. For aristocracy is valuable to the public acceptance of this kind, for having nobody to sympathize with it, and when a capitalist is within 20 years old, the population is said.
Now this was the overall papers that the Facebook AI was providing for the Textless NLP. This was using this idea basically without using any of the NLP domains or knowledge for some of the language that where NLP hasn't been touched upon. We can still work on speech generation or speech synthesis task, which wasn't been possible previously. There was some code also which they have provided. Let's look at that also. So now in Python actually they have provided the examples and if the preterm models of the speech to unit model, the unit language model and unit to speech model, which if needed we can utilize for our models as they have provided a preterm model. It's just that we need to integrate all of these things and to provide those results. So if you want to check the code out and want to check the outputs, you can actually use this model and you can test on your input sequences also. Now we have skimmed up a lot of the things where they have used k-means to actually get only the main context values from the words, removing the noise from the encoder and the logmail filter band modeling in the output, which most on the voice types they use, which actually just increase the lower frequency values and decrease the high frequency values. This is as a filter for that. However, if needed, you can go over the paper, and if needed any help, let me know in the comment section. I will be providing more context on there as per the needed. And that was it. If there, as this is, I am the voice based text generation is some kind of a new topic for me also. If there will be any changes or any other more context, you can mention on the comment section. And if you want more, if you have some more topics that I should cover, let me know and see you in the next part. Thanks.